Today we will be learning about the electric charges. First, let me introduce to you electricity. You already know about electricity. Almost everything requires electricity. The fan, the tube lights, the refrigerators, everything requires electricity. The atoms, molecules, and the chemical reactions also work because of electricity. Your heart beats because of electricity. Also, you hear and see because of electricity. There are electrical impulses because of which we can see, we can hear. Even when you think because of electricity. Now, about charges, there are two types of charges, as you know. One is the positive charge and the other is negative charge. Conventionally, we say proton has a positive charge and electron has a negative charge. The charge on one electron is 1.6 into 10 to the power minus 19 coulomb, where coulomb is the unit of charge. Coulomb is a very large unit of charge, so in practice we do not use coulomb, but we mainly use micro coulombs. The charge on one proton is also same. The only difference is that the electron has a negative charge, whereas the proton has a positive charge. How can we charge an object? There are several ways in which we can charge an object. One of them is charging by friction. If I have an object over here, let us say this is a plastic and this is wool. If I rub them like this, the plastic becomes negatively charged and the wool becomes positively charged. Now, plastic क्यों negative होता है, wool क्यों positive होता है? You can search it on the internet. There is a trigoelectric series, and according to that, this becomes negatively charged and this becomes positively charged. So when I rub this, it is already charged because of friction over here. Now the other way of charging is charging by conduction. If you have a metallic object which is having some charge, and if you touch another metallic object with it, then some of the charges would go from one metal to the other metal, that is charging by conduction. And the third way in which you can charge is charging by induction. अब इसमें हम एक मेटालिक स्फीयर लेते हैं. Let us say we take it a sphere with an insulating stand over here, and now we bring, let us say, a plastic scale जो नेगेटिवली चार्ज पहले से है, और यहाँ इसको इसके पास लाते हैं, तो ये sphere, because it's a metallic sphere and metal has free electrons, तो charges move हो सकते हैं, the electrons can move, और क्योंकि इलेक्ट्रॉन और इलेक्ट्रॉन लाइक चार्जेस है, they repel each other and they try to go away from each other, and the positive charges then in that case are over here. Now अब हम यहाँ इस मेटल के साथ अगर एक दूसरा मेटल टच करे तो ये जो इलेक्ट्रॉन्स यहां है, जिसको पहले जाने की जगह नहीं मिली बिकॉज देयर वाज ओनली वन स्फीयर, बट नाउ व्हेन आई टच इट विद द अदर स्फीयर, दिस इलेक्ट्रॉन कैन इजीली ट्रैवल into this sphere because it's also a conductor, and so the electron goes like this. Now without removing this, इसको हम यहीं रहने देते हैं और इन दोनों स्फीयर्स को अलग कर देते हैं. Now you can remove this also, and what you see is that this sphere is now positively charged and this sphere is negatively charged. अगर ये दूसरा वाला स्फीयर तुम्हें दूसरा मेटेलिक स्फीयर नहीं लाना है तो उसकी जगह कुछ और भी रख सकते हैं. एक बहुत बड़ा स्फीयर अर्थ, इसको अर्थ के साथ कनेक्ट करते हैं. दिस इज अ सिंबल जिससे हम बताते हैं कि हमने अर्थिंग कर दी है, अर्थ के साथ कनेक्ट कर दिया. सो थ्रू दिस वायर these electrons can now go back, now go into the earth, and now I will touch the connection over here so that these electrons cannot come back again after removing this, and you can see now that these positive charges after removing this would rearrange, and then you can get this as positively charged sphere. Now let us try to see these things practically. The instrument or the device which detects charge is called an electroscope. इलेक्ट्रोस्कोप में एक मेटल का नॉब होता है और रॉड के नीचे एल्यूमिनियम फॉइल है, गोल्ड लीफ है. Now this is like this. If I bring a charged object over here, तो ये चार्जेस यहाँ से अंदर जाके इन लीव्स पे आते हैं, and because both the leaves get the same charge, it goes apart. Instead of this, there are certain electroscopes which instead of having two leaves are having only one leaf, जैसे कि मेरे पास है. So in this case, the positive charge or any other charge, whatever it may be, it goes like this, and therefore these two are positive now, and so this thing which can fly off, it will move apart. Let us see if things work out. I have an electroscope over here. I have a plastic scale and a wool. So you rub it with it. You clearly know now that this is charged. I'll bring it near the electroscope and you will see the leaf going apart. If I remove this, the leaf again comes back down. वापस करते हैं, ये दूर गया और ये वापस चला गया. I am a very good conductor. Human beings are very good conductor. तो अगर मैं इसको यहाँ पास लाता हूँ, and if I touch it with my finger, as you can see, what happens is I take the charge away, and because of that this again comes back down. Now see this. इसे चार्ज करते हैं and I bring it over here. I put my finger over it and take away the charge, and now I take away my hands and the scale both in this way. What you see is that the charge was taken away and therefore the leaf has fallen down. Now let us see it once again. You bring this rod over here. I'll charge it a little more. And now you touch it and now you remove both the things. Oh, did you see something interesting over here? इस बार ये लीफ फॉल होने के बजाय वापस दूर चला गया. ऐसा क्यों? Think about it. Alright, so here we have one graph generator. It produces a lot of charge, and the charge gets stored over here on this dome. Of course, as it produces charges, the voltage is very high, thousands of volts, so it's not a very easy experiment. Now what I'll do is I will charge this first, and I put this pointed wheel up over here. So when this will get charged, the wheel will also get the charge of the one digraph, and because of which the wheels will start rotating as these both will have the same charges, so they will repel each other. So let us see this. And you can see it's already rotating. So because of the charge which is produced in the pointed wheel. Let me take off the charge. We have this another sphere over here which is used to take off the charge from the one digraph. I'll show you if you can see the sparks, or at least you will hear that. Can you see? Or at least you will be hearing. I'm also getting it. Now let us see this. There are balls over here, and I'll put this in like this. Now what happens is that this one digraph gets charged, and because of which this will be repelling and will try to go up. Let us see that. And you can clearly see these going up because of the repulsion. Okay, now let us try to see it on this. So put this in over here, and this is a ball hanging with that first silk string. And you can see the first gets sucked in, and then it is repelled. So as it's a non-conductor, it first gets sucked in because of the charge which is over here, and as it touches it, it gets the same charge as this, and therefore it gets repelled. अब चार्जेस की कुछ प्रॉपर्टीज हैं. पहली is the additivity. If I have some charges over here, plus 3 coulomb, plus 2 coulomb, minus 7 coulomb, plus 1 coulomb, then the total charge over here can be added algebraically, and therefore the total charge over here will be 3 plus 2 5 plus 1 6 minus 7, that is minus 1 coulomb. This is the additivity for charges. दूसरी प्रॉपर्टी जो काफी लोग जानते हैं वो है कंजर्वेशन ऑफ चार्ज. That is, charge can neither be created nor destroyed. It can only be transferred from one body to another, as I showed you in the experiments. It can only be transferred, but it can neither be created nor destroyed. अगर आपके पास शायद बचपन में किया हो कि स्केल हो, स्केल को बाल के साथ रब करते हैं और पेपर के पीसेस पर डालते हैं तो उसके साथ चिपकने लगते हैं. जब बाल के साथ स्केल को रब करते हैं तो स्केल नेगेटिवली चार्ज होता है, प्लास्टिक स्केल, एंड योर हेयर बिकम्स पॉजिटिवली चार्ज. बट बिकॉज यू आर कंडक्टर, चार्ज तुम में से फ्लो हो जाता है, बट स्केल नॉन कंडक्टर है इसलिए उसमें चार्ज रह जाता है. बट इलेक्ट्रॉन्स तुम्हारे बाल से ही स्केल में गए हैं इसलिए चार्जेस आर नॉट क्रिएटेड इन द स्केल and neither the charges are destroyed. The third property we have is the quantization of charge, which says that the total charge is the integral multiple of fundamental charge E. E is a charge on one electron that is taken as the fundamental charge, and so the total charge, that is, let us say Q, is equals to NE, where N is an integer, 1, 2, 3, 4, 5, 6, could be any number. So if you have one electron, you have 1.6 into 10 to the power minus 19 coulomb. If you have two electrons, then it's the double of that, and if you have three electrons, it's the triple of that, and that way you can have the total charge equal to Ne. That is the quantization of charge. In a macroscopic world, the quantization is ignored because the charges which we deal with are much larger than the charge on a single electron. Now let us try to be more quantitative, और अब हम Coulomb's law से start करते हैं. What is Coulomb's law? If I have two charges, let us say Q1 and Q2, which are separated by some distance, let us say R, then according to Coulomb, the force between these two charges is directly proportional to the product of charges, and it is inversely proportional to the square of the distance between them. अब अगर दोनों को साथ में लिखें तो you get F proportional to Q1 Q2 by R square, and if we remove the proportionality constant, if we remove the sign of proportionality, we have to put a proportionality constant K Q1 Q2 by R square. Here K is a proportionality constant often called as Coulomb's constant, जिसकी वैल्यू है 9 into 10 raised to 9, and तुम इजीली इसके ऊपर से इसकी यूनिट निकाल सकते हो. This is Newton and this goes over there, this is meters, so meter square, और ये चार्ज Coulomb, and you get Coulomb square. So Newton meter square or Coulomb square is the unit of this. Historically, K is also written as 1 upon 4 pi epsilon 0, where epsilon 0 or epsilon naught is called the permittivity of free space. And its value is 8.85 into 10 raised to minus 12. I hope we'll be able to figure out what is its unit. It's very easy. So this is the force according to Coulomb, K Q1 Q2 by R square. If we compare the Coulomb's force K Q1 Q2 by R square with the gravitational force given by Newton, G M1 M2 by R square, it's very similar because this is also proportional to 1 over R square, and this is also proportional to 1 over R square. फर्क ये है कि यहाँ चार्जेस है और यहाँ मासेस है. Charges can be positive and negative, but masses can be only positive. and therefore the Coulombian force can be repulsive also and it can be attractive also. अब इस कूलम्ब लॉ को हम वेक्टर फॉर्म में कर देते हैं. Coulomb's law in the vector form. So if you have a charge Q1 over here and a charge Q2 over here, which is separated by a distance r, let us for now let us take these two charges as positive. तो इसलिए ये इसके ऊपर फोर्स लगाएगा, ये इसके ऊपर फोर्स लगाएगा, बिकॉज ये लाइट चार्जेस हैं, तो ये इसके ऊपर इस डायरेक्शन में फोर्स लगाएगा. दिस इज द फोर्स ऑन 2 ड्यू टू 1, और ये इसके ऊपर इस डायरेक्शन में फोर्स लगाएगा. दिस इज द फोर्स ऑन 1 ड्यू टू 2. नाउ दिस डायरेक्शन is r21 because according to vectors we just studied, r21 is r2 minus r1. So let us take this direction is r21 and this direction will then be r12. So if you want to find out the force on charge 2 due to 1, then that will be equal to, according to the Coulomb's law, k Q1 Q2 by R21 squared R21 cap, because F21 and R21 are in the same direction. And in the same way, if you want to find out the force on 1 due to 2, that will be equal to K Q1 Q2 by R12 squared R12 cap. These charges which we have taken over here, these are the point charges. So no point charges. These are not extended bodies, but these are point charges. What if there are more than 2 charges? तो उस वक्त force कैसे calculate करें? To calculate the force for more than 2 charges, we use the principle of superposition. ये चीज आप लोगों ने 11th में भी की है, सुपरपोजिशन प्रिंसिपल. So if we have many charges, let us say Q1, Q2, Q3 and so on to Qn, this is having the position vector r1, this is having position vector r2 and so on. So this then is R21 this. Now if you want to find out the force on Q2 due to the other charges, then we can, how we can do is, हम पहले इसकी वजह से फोर्स फाइंड करेंगे, फिर इसकी वजह से करेंगे, फिर इसकी वजह से करेंगे और सारे फोर्सेस को ऐड कर देंगे. So what you get is the force on 2 is then equal to the force on 2 due to 1, the force on 2 due to 3, or force on 2 due to 4 and so on, force on 2 due to n. So then the force will then be equal to K, in this case Q1 Q2 by R21 square R21 cap, and in this case it will be K Q2 Q3 by R23 square R23 cap and so on. You can then take out K Q2 common because they are everywhere, and so what remain over here is Q1 by R21 square R21 cap plus Q3 by R23 square R23 cap and so on. इसको अगर हम mathematical form में लिखें तो we can write it as K Q2 sigma. Now this is Q1, Q3, Q4, Q5, Q6, and then you can write it as Qj where j is from 1 to n, but of course here in this particular case j is not 2 because 2 is there already outside. And so what you get is r2j square r2j cap. And if we generalize this, we get the force of any of the charge equal to k qi. We take this is qi now, sigma qj by r ij square rij cap. This is the principle of superposition. Of course हम superposition के principle को prove नहीं कर सकते हैं, but still we use it because it is consistent with all the experimental situations. Now I want to give you one example so that the concept goes through you. And so let us start with one very good example. Suppose I have two charges. Let us say एक है +5 कूलोम और एक है यहाँ पर +5 कूलोम है और यहाँ -3 कूलोम। इन दोनों चार्जेस को मैं फिक्स कर देता हूँ ताकि वो मूव ना कर सके। और I bring another charge, a very small charge, let us say 1 coulomb charge only, and I put it over here, very near to this charge. देखना और बताना ये है कि इस चार्ज के ऊपर फोर्स कौन सी डायरेक्शन में लगता है। +5 is trying to push it because both are positive, and -3 is trying to pull it towards it because both are unlike. तो कौन सी डायरेक्शन में ये जाना चाहिए? It is going this direction. Reason? Because it is near to the -3 coulomb charge and therefore it will dominate. So the force will be in this direction. अगर मैं वही चार्ज 1 कूलोम वाला यहाँ न रखकर, if I put it very far away, let us say over here, अब ये कौन सी डायरेक्शन में जाना चाहिए? Well, again -3 is -3 is closer to this, but then this distance is way too larger than the distance between these two charges, and therefore these two charges will behave as one only, and that will be equal to +2 coulomb, and then in that case this is positive, and so it will try to repel this, and the force will be in this direction. यहाँ पर फोर्स जो -3 कूलोम्ब की एनर्जी के लेफ्ट में है, यहाँ पर फोर्स जो एकदम दूर है वो राइट में है, तो इट इज वेरी ऑब्वियस दैट समवेयर ओवर हियर इन बिटवीन देयर मस्ट बी अ पॉइंट where the net force is 0. अगर हम दोनों चार्जेस लाइक लेते हैं +5 और +3, so in this case if I bring a small charge over here, this will experience a force in this direction because these both will repel, and if I bring it over here also, then also it will feel the force in this direction only because again there is a repulsion. So clearly there is no point over here where the force is 0, and the same thing happen over here also. There is no point over here where the force is 0, but if we go in, then what will happen? If we have a charge somewhere over here, then this would try to push it in this direction, and this would try to push it in this direction. So now in between them there are places where the force applied by both will be in the opposite direction. So somewhere there will be a point where the force on this is equal to 0. If both the charges are of same value, then it's very clear that the force will be 0 exactly in the middle. So what we learn from here is that the net force becomes 0 at a point which is, if the charges are unlike charges, then it will be 0 outside and not in between them, and outside also will be near to the smaller charge value. In the same way, if there are two like charges, then the net force will be 0 in between them, and of course again it will be near the smaller value. Thank you.